Welcome to the HAEST videos for undergraduate studies. I'm Professor Tim Leung from the School of Science at HAEST. I'm going to introduce you our new undergraduate program, Data Analytics in Science. We are living in a world full of data. It is estimated that 1.7 meg of data is created every second for every person on Earth. Here is an example. You are now streaming this particular video. A high-quality video uses around 1 gigabyte of data per hour. Another example is a credit card transaction. It is estimated that 185.5 billion purchase transactions are made worldwide using Visa card in a year. Credit card payment is not the major means of transactions in Hong Kong, but we are still talking about around 800 million credit card transactions per year. To us, we use the Autopass card more often, and here we are talking about 3.5 billion transactions a year. Because of the huge amount of data that we can record, we are now able to extract and explore any possible hidden information in this world of numbers. The first thing that we would like to do is to understand the underlying phenomena from all these measurements. From the history of what you have watched, companies would like to understand your preference and taste. From the understanding of what these numbers mean, we also want to make predictions and to draw some new insights into the real-world event. Your video watching history can tell people your preference. From this information, companies will be able to make relevant recommendations. A second example, from the transaction history, companies would like to understand your purchasing habits, and then they can make good predictions of what you might like and therefore can have a better marketing strategy. Seeing the needs for employees with trainings in data analytics and also the interests of our students, the School of Science has just developed this new undergraduate program called Data Analytics in Science, and we call it DASC. To understand and draw new insights from any data set, one needs what we call data analytics tools. It requires some basic knowledge from mathematics. Students in this program will then have a chance to practice and sharpen their skills on some data sets from science. Through these examples, students will also see how data analytics revolutionizes the development of modern science. This program is not a conventional science program. Conventional science education programs focus more on data collection through experiments and observation. This program, however, is structured in such a way that students will be equipped to analyze, present, and draw insights from data in context using knowledge of mathematics and software. This program does not aim to train future scientists or researchers like our popular IRE program. DASC, on the other hand, wants to teach minimal amount of science so that we can still name our degree a Bachelor of Science, but at the same time, we want to provide our students with some hands-on experience in data analytics so they can easily adapt to any data-intensive career in the future. Because of this new philosophy in training our science students, we have also decided a special study pattern for our students. In the first 2 years, students will take some basic science foundation courses and math courses. In the year 3 and year 4, students will concentrate their studies on one of the science tracks. Students choose one track in a scientific field to practice and sharpen their skills. Courses in the tracks are not meant to train students to be experts in the corresponding fields, but rather to bring them into the context of a domain of data-intensive field in science. Let me show you some examples of how data analytics has been applied to these scientific fields. We have many data collected from the satellites. We can have measurements such as temperature on the Earth's surface or the ocean surface velocity. The problem is that it is difficult to visualize the data and be able to draw relevant insights from these graphs. Can we say anything about global warming from these measurements? How bad is the situation in the ice cover in the two poles? We can use data analytics tools to predict future weather changes from historic data. There are many important applications of data analytics tools in the field of biology. One example is a recent study on microbiomes that suggests certain gut bacteria might link to certain diseases. The idea is to collect bacteria samples from different patients with different diseases. If you can find a similar bacteria from many samples of the same disease, it suggests scientists have a more careful investigation. DNA sequencing also involves many data techniques. Also, if you can obtain your whole DNA sequence, data analytic tools can help to identify the potential gene-related disease. Data analytics also changes research in chemistry. We have complete data on how to relate certain chemical structures with their biological properties, but we required data analytic tools to help to predict the performance of any new giant drug molecules. You cannot avoid obtaining data in experimental physics. In CERN, for example, the Large Hadron Collider, LHC, produces 600 million collisions every second in each detector, which generates approximately 1 petabyte of data per second. It is a big challenge on how to identify the occurrence of any rare events, such as the discovery of the Higgs boson. You can easily find many other examples in different scientific fields that rely heavily on the use of data analytics. We are not only teaching our DASC students how to play with scientific data, but also want them to be able to bring all data analytic techniques into practice in any data-intensive fields. Here are some real-life industrial projects that our DASC students can easily handle with the skills they equipped. In the middle, I am showing you a project proposed by the Hong Kong Observatory for an undergraduate summer research project. The current weather prediction model takes many weather forecasts from around the world and then tries to identify which forecast might give the most reliable prediction. This involves the same skills as the microbiomes example that we introduced earlier for the applied biosciences track. In that example, students look at all bacteria samples and try to identify which bacteria are mostly responsible for a certain disease. The second example is the one on the top right corner. One of our former students was working in the Airbnb as an intern. Her company got many data and proposed to use the available data to predict the pricing of a new rental. The machine learning techniques that our student worked on can be easily found in any recent data research in science. It is also important to have a computer system that can automatically identify fraud in credit card transactions. One possible approach to the problem is to use the same data analytic tools as in the drug design problem, where we want to predict the property of a certain new chemical on our body. The School of Science provides 5 admission programs. They are IRE, Science A, Science B, and then MAEC, Math and Econ, and also BBU, Biotech and Business. DASC is not a program choice at JUPAS at the moment. DASC follows the school-based admission and is a program under our Science Group A. If you are interested in taking DASC as your major, you have to join our Science A first, and then you can try to declare it once you finish your first year at HAUST. For Science A and Science B, we will take approximately 200 and 260 students respectively. For DASC, we are setting a quota of around 100. We believe this is large enough to accept everyone who might be interested in it. The last thing that I want to mention is the admission requirements and admission score formula. For JUPAS students, the minimum requirement for Science A is 332233. We use our weighted best 5 formula. We give extra weighting to your English and also weightings to at most 2 science electives. Since DASC expects students with more training in math and physics, we put an extra weighting of 2 to the DSC subjects including physics, M1 and M2. If you have other science subjects such as chemistry, biology, or combined science, we will still give them a weighting of 1.5. Alright, this is all I want to say today. If you have any questions, feel free to contact us. If you want more information, follow us on Facebook and IG. Thank you for watching the video. And I think you should have better knowledge about our Data Analytics in Science program. Finally, we hope we can see you at our campus in the near future. Thank you.